Hello class, for the sample problem number 3, the problem is the rigid bar ABC shown in the figure is hinged at A and supported by a steel rod at B. Determine the largest load P that can be applied at C if the stress in the steel rod is limited to 30 kSI and the vertical movement of NC must not exceed 0.10 inch. Okay, for our solution, what is being required in the problem is the maximum load P that can be applied, considering first the allowable stress. So let us consider first the allowable stress of steel. Okay, the allowable stress of steel, which is equivalent to 30 kilopounds per square inch or 30,000 pound per square inch or PSI. Okay, from the previous lesson on the stress, so stress is equivalent to force per unit area. So applying this equation in this problem, we have the allowable stress for steel, which is equivalent to 30,000, and then that is equivalent to the P steel over its cross-sectional area. Okay, so the cross-sectional area of the steel is 0.5 square inch. So this is 0.5. So therefore, we have P steel equivalent to 15,000 pounds per square inch or PSI. Okay, steel similar to 15 KSI, sorry. So that is KSI, kilopounds per square inch. Sorry guys. So the unit for P is pounds only. So just remove the inch. Sorry. So this is kips. 15 kips. Okay, 15 kips. Okay. So we have already the magnitude of P steel considering the allowable stress dito sa steel. Okay. So another one is to consider the vertical movement of NC. So based on the problem, the vertical displacement of C must not exceed 0.1. Okay, so once loaded kasi to clash, okay, the assembly is, or the rod AC is supported at A by a hinge and also supported by a steel dito. Then this one is the point C. The condition in the problem is that the end C must not exceed 0.10 inch. Okay, class. Once the load P is applied, what will happen to the rod? So, mangyayari sa kanya, class, ma-rotate itong rod. So, wala namang displacement sa A kasi supported siya dito. So, yung point A pa din siya. But point C, once the load P is applied, so magkakaroon ng deformation itong steel, mag-elongate siya. So, obviously, intention yan. So, ibig sabihin, kapag nag-rotate ito, bababa yung point C. So, ang allowable movement niya lang is 0.10 inch. So, pag in-sketch natin yung class, so let us draw the original position of the rod AC. So, initially, it is horizontal. So, once the load P is applied, so, marirealize mo, magro-rotate yan. Exaggerate lang natin, although the deformation is unnoticeable. So, this is the displacement of C and is limited to 0.10 inch. Okay. So, in-apply mo tong P. So, itong from C, nandito na yung C prime. So, this is the vertical displacement of C. Now, itong point B, so this one is point B. So, pupunta na dito yung B prime. So, actually, this is assumed to be vertically yung movement niya. Pero in actual, sa reality, magro-rotate siya class. So, therefore, makaka-form siya ng arc. Something like this, di ba? So, the C prime should be here, di ba? In actual. But since this angle of tilt itong angle of tilt natin or the angle of rotation is very small lang naman yan class. So it is assumed that C to C, let's make it a C double prime. So yung C to C double prime is an arc. So hindi siya directly below originally yung point C, hindi siya vertical yung point sa reality. Pero since this is very small, yung theta, unnoticeable yan, so it is almost assumed to be a straight line downward. No? So, okay, in this problem, we are going to assume that the displacement is vertically downward, directly below C. So, this is now our effective final position of point C after the load is applied. Okay, so it is limited to 0.10. And then this one is the displacement of B. Okay, so therefore this is equivalent to delta P. So this is the vertical displacement of B. And by observation, ma-realize mo that this is also equivalent to the deformation of steel. Yung ibinaba ng point B, na yung inelongate ng steel. Okay. Now, considering, based on the problem, another situation is that the end C must not exceed 0.10 inch. Therefore, by ratio and proportion, okay, consider delta C is equivalent to 0.10 inch. Okay, by ratio and proportion, we have displacement of B over 2 feet or 2 multiplied by 12 to make it in inches. Anyways, you can use 2 feet lang naman because on the other side of the equation, the denominator is also in feet, so maka-cancel out lang yan. But to be safe, for other problem kasi sometimes nagkakaroon ng error kapag feet, lalo na kapag yung theta yung hinahanap. Na? Okay, so delta B over 2 times 12, 2 feet kasi class, by ratio and proportion, this one, delta B over 2 by similar triangle, that is equivalent to delta C over 5 feet multiplied by 12 to make it in inches. Now, since delta C, we have delta C equivalent to 0.10. Therefore, we can say that the delta B, therefore, delta B is equivalent to, okay, cancel out lang din naman class yung 12. You may cancel it out. So, 0.10 multiplied by 2 divided by 5. That is equivalent to 0.04. 0.04 inch. Okay, so from a similar triangle, we have determined the vertical displacement of B. As I have said earlier, the displacement of B is also equivalent to the elongation of steel kasi nung in-apply mo na yung load P, mag-elongate yung steel. Therefore, yung point B mo, magkakaroon ng vertical displacement downward. So, magkakaroon ka ng displacement of B. So, that is equivalent to the elongation of steel. So, we may equate the deformation formula equivalent to, the deformation of steel is equivalent to the displacement of B. Okay, so we have PL over AE of steel is equivalent to 0.04 inch. Okay, substitute, we have P steel multiplied by the length of steel, 4 feet by 12. Okay, to make it in inches, cross-sectional area equivalent to 0.5. And then the modulus of elasticity is equal to 29 times 10 raised to 6. So equivalent to 0.04. So we can now determine the value of P steel to be, okay, so we have 4 or 0.04 multiplied by 0.5 multiplied by 29 times 10 raised to 6 divided by 4 by 12. So therefore, we have 12,083, 12,083.33 pounds. Okay, pounds. Sorry. So, or 12.08 kips. Okay, so this is now our P still, considering the NC to be 0.10-inch maximum yung vertical displacement. Okay, comparing the two results, we have 15 kips and 1208 or 12.08 kips. So now, what is the final answer? So the final answer, because we are determining the largest value of P, na kung saan hindi mag-exceed sa allowable both and the displacement of C. So therefore, the final answer for the load P is equivalent to 12.08 sa steel. But ang hinahanap natin, class, is the magnitude of P. Diba? Okay. So, since magnitude of P yung hinahanap natin, okay, we have finalized that we are going to use P still to be equivalent to, sorry. So, we have, from the, hindi pa ito yung final answer, class, yung P still, because what is being required in the problem is the load P pala. No? Okay, so we need to get a relationship of P still and P by using static equilibrium. Okay, equation of static equilibrium, take moment tayo sa A. Okay, summation of moment at A equivalent to 0, magkakaroon tayo ng, okay, so visualize nyo yung free body diagram, or simply, ito yung free body diagram, class. So this is P, so this is P still. This is P, ito yung P still. So this one is 2 feet, ito ay 3 feet. So at this point, hinged siya, meron siyang X and Y reaction, diba? But since magte-take moment naman tayo at A, so mani-neglect lang din siya. So taking moment at A equal to 0. Okay, so we have clockwise positive tayo. So we have 5P is equal to, or kung sanay kayo nang hindi na muna diretsuhan, minus 5P minus yung counterclockwise, P still multiplied by 2, or 2P still equivalent to 0. Now we have a relationship of P and P still to be, okay, 5P is equal to 2P still. So P is equivalent to 2/5 of P still. Okay. So since we have two values of P, okay, this one is considering the allowable, so hindi siya mag-exceed, and then ito naman yung as a deformation or sa displacement ng C. So, considering P still is equivalent to 15 kips, we have P is equivalent to 2/5 of 15,000. So, therefore, P is equal to, okay, so 6,000. So, we have 6,000 pounds, or 6 kips. Okay, considering P still equivalent to 12,083.33 pounds, we have P equivalent to 2/5 of 12,083.33. So, P natin ngayon will be equal to 4,833 4.33 pounds or 4.83 kips. Okay, so between the two results of P, we have 6 kips and 4.83 kips dito sa required hinahanap na largest load P. Okay, the final answer class is P. Therefore, P is equivalent to 4.83 kips. Okay. So, hinahanap is largest pero bakit hindi yung 6? Diba? Because we are required to determine the maximum safe. So, ibig sabihin class, when it comes to the deformation of, or when it comes to the displacement of C, so 4.83 kips yung P. Hindi siya mag-exceed ng 0.10 inch kapag ang P natin is 4.83. So, kapag ginamit kasi natin ay 6 kips, so mag-exceed yun, obviously, sa 0.10 inch yung displacement ng C. Kapag naman, when it comes to allowable stress naman, kapag ginamit natin ay 6 kips, okay, hanggang 30 KSI siya may stress. Considering the allowable stress, ito yung load na 6 kips, di ba? Pero pag niload mo dito, ma-exceed naman siya dun sa displacement. Kaya, so, ito ang pipiliin yung class. Pag sinahanap yung load, take note, pag load ang hinahanap, yung mas mababa para kaya niya when it comes to the deformation, and also dun sa allowable stress. So, when it comes to allowable stress kasi, ang kaya niya hanggang 30 KSI kapag 6 kips. Eh di what more kung ang load P is only 4.83, di ba? So, hindi siya ma-exceed talaga sa 30 KSI. Okay, so the final answer class is 4.83 kips. Okay, that's all for this video.